This is question 5 of atomic structure tutorial. Okay, over here you see two graphs, one on the left and one on the right. Okay, what trends are they? Okay, the first one over here, order of electrons removed. Okay, so this is a successive IE trend. Okay, the second one, atomic number. Okay, and over here it says third IE. So this one is across the period trend. All right, so keeping this in mind, okay, let's look at the question. Okay, the question wants you to identify which group element Z is in. Okay, element Z. Okay, element Z. So which one will you use? Will I use the successive IE? Yes, you should. Okay, you should use successive IE to determine the group number for element Z. Okay, so for successive IE, we look at the sharp increase. So this is a sharp increase, and our conclusion is that the first 3 electrons before the sharp increase are taken from the outermost quantum shell, right? Okay, so that's our conclusion. Okay, it has 3 valence electrons, and therefore this is group 13, right? Okay, so that's pretty easy. Then write the ground state configuration of Z. Okay, it expects you to write the quantum shell number. That means either 2 or 3. Okay, how do you tell? Okay, over here, I think there's some information. Element Z has an atomic number of below 20. Okay, we look at the periodic table. Okay, which are the elements in period 3 that's below 20? Okay, below, not period 3, group 13. Okay, group 13. Okay, below 20 is calcium. Okay, 20 is calcium. So we should be looking at aluminium or boron, right? Aluminium or boron. Gallium is already more than 20, so we won't consider that. So either aluminium or boron. So should you use period 2 or period 3 element? Okay, let's come back here. Okay, if Z is a group 13 element and it has a atomic number of below 20, okay, it's either aluminium or boron, period 2 or period 3. Okay, we can't really answer that yet. Okay, I would suggest that perhaps we look at part 3, then we can answer part 2. Okay, part 3. Okay, based on figure 2, state which element A to G could be element Z. Okay, across the period trend. Okay, we are going to decide A, B, C, D, E, F, G. Which one is element Z? Okay, we know that this is a group 13. Okay, element Z is group 13 element. All right, so which one is group 13? Is it G? No, because over here, third IE. Remember, I cannot use the first IE concept, right? So third IE, the one with the lowest, is group 13, right? So this is group 13. Does it correspond to your group 13? Yes. So Z is element, E is your element Z. Okay, right? Now we got to decide. This period, is it a period 2 or period 3? Okay. If this is period 2, that means this is period 1, no? Period 1, can period 1 have so many elements? Not possible, right? So this has to be period 2, and hence this is period 3. And our conclusion for Z is that Z got to be in period 3. Okay, you understand my argument? How I managed to conclude that Z is in period 3? Because Z belongs to this period. Okay, and the period before that has more than 2 elements. So this period cannot be period 1. It has to be period 2. And hence it is period 3. right? So knowing that element E is E is element Z, then we have also concluded that element Z is in period 3. Then we can write the full electronic configuration with 3s2, 3p1. Okay. Now part B, explain the increase in the third IE. Okay, between F and G. Okay, we look at the graph again. F and G. Okay, in fact, from F to G is a drop. Okay, why? Remember the anomaly, the first anomaly in the cross the period trend in the period. Okay, the anomaly is because of the removal of 3p electrons. Okay, having higher energy or further away. Okay, compared to removing the 3s electrons. Okay, so the explanation is similar to one of the questions. Okay, in question 4. All right.